Hello class, so we're going to basically start doing some free-fall problems using kinematic equations. If you look on, it's the second page of your packet that's in there. We're going to work letter D, and so here we go. A stone is dropped into a deep well and is heard to hit the water 3.41 seconds after being dropped. Determine the depth of the well. Well, first off, ignore any sort of time that it would take. Just consider that the sound was immediately heard. It was when the noise was made. So when it drops, it's all said and done. So just simplifies the problem a little bit. Not that y'all are thinking that, but I don't know. Some people think that sometimes. So a stone is dropped into the deep well and is heard to hit the water at 3.4. So I'm going to write down D, A, VI, T, VF, and then T. And see what we got. Stone is dropped into a well. 3.41 seconds. 3.41 seconds. All right. That's not a lot of information. So there must be something that is inherently known. And yes, there is. What is one thing that is inherently known about all free fall problems? It's the acceleration, which is also variabilized. The other variable for it is g. And g is negative 9.8 meters per second squared. Things always accelerate at 9.8 meters per second squared downwards. I'm just going to use the negative sign to sort of say the general conventions of positive is up, negative is down, and away we go. And then it also said dropped in the well, meaning held stationary and released. Dropped means that I have an initial of a 0. Now I got 3. If I have 3, I can do 4. Which one do they want to know? They want to know distance or displacement. Because it's being dropped, there's no change in direction, so distance is equal to displacement. But they want to know the D. They want the D. So, here we go. I don't have a VF, nor do I care about a VF. So let's find the one without a VF in it. It's that one. D is equal to VI times T plus 1/2 AT squared. D, VI. When VI is 0, isn't that just going to get rid of that? Isn't that just going to get rid of that? So what does it matter? So D is equal to 1/2 negative 9.8 T squared. And time was, sorry, I should just put that in immediately, 3.4 squared. So this ends up looking like negative 4.9 times 3.4 squared. It's 11.56. So negative 4.9 times 11.56 is negative 56.64 meters. It fell over a football, over half of a football field. So it's things fall relatively quickly, considering that it fell for 3.41 seconds. So there's your depth, that is the distance that it traveled, the displacement. It's all in the same direction, so they're equal to each other, which is ultimately the depth. So now, the fatal kangaroo problem. I'm just going to enter my kinematic equations just for future reference right up there. All right, kangaroo. A kangaroo is capable of jumping to a height of 2.62 meters. Determine the takeoff speed of the kangaroo. Okay, so this problem is tricky. There's no doubt about it. We got a kangaroo that's jumping, and they tell us that all they tell us is that it jumps to a height of 2.62 meters. So I got D, VI, I've been putting A, so I'll just put A in there. A, VI, VF, and then T. Yeah, I can see that. So the distance, the only thing that gave me is a height. The only thing that gave me is a height. So I'm going to fill that in. Okay, I know that ultimately he jumps up and he jumps back down. We can do a hang time. No, they don't give me that information. I don't have time. I wish I knew a hang time. If I knew a hang time, it would be easier, but I don't. So I have to use some special rules. In the Freefall video, I talked about some special rules. I said that at the maximum height, what is the velocity? Well, at the max height, the velocity is 0. And so 0 is 0 is 0. We're doing it in meters per second. Let's figure that out. So the V at the top is there, and they want to know, what is the VI? So if this is my final distance at the maximum height, because that's the height that he jumps to, and this is the velocity at the maximum height, then that becomes my VF, and my VF is 0. Now, I need one more. It's a free fall problem, so it's negative 9.8 meters per second squared, because that's gravity, because this is always the same. Unless you're on a different planet or a celestial body such as the moon, which A does that, but they give you the acceleration. They're going to have to give that to you, or they might even ask you to calculate the acceleration due to gravity on a different planet. But as long as you're on Earth, which kangaroos live on Earth, we're good with the negative 9.8 meters per second squared. So here we go. I'm looking for one without a VI. Well, they all have VI, but I also am looking for one that without a T. So which one doesn't have a T in it? That'd be VF squared equals VI squared plus 2AD. So my final is 0. My initial is, I don't know. And then this is negative 9.8 and my height, which is 2.62. So this is what I would do. I would combine these terms to get 2 times 9.8 times 2.62, and this would turn into negative 51.352, and ultimately when it turns into a negative, that becomes subtract, and we get left with a 0. Now I can move to the other side. I can add 51.352 to the other side, and it becomes 51.352, and then that cancels out. And so VI is squared. If I only find the square root of this, I can know that the kangaroo jumped up at 7.166 meters per second. And there is your takeoff speed. That's how fast they were going when they took off. All right. Like I said, if you have any questions, feel free to email me, and I will see y'all on Monday, hopefully. Y'all have a good week.